Hello, can you guys hear me? Nice. So before I start my talk, I wanted to ask you guys a question. How many of you here are database developers? 1, 2, okay. You know, someone told me that I should probably start my talk with a joke. The question is not a joke. I'm seriously asking you the question. How many of you here are web developers? Nice. So you know what? Talking about storage and databases to a web developer audience, it's not always fun. So I thought I'll add a little bit of Star Wars to it. And here's the Star Wars-based theme for IndexedDB. Let me start with a simple story. A long time ago, in a galaxy not so far away, there was this big problem called storage wars. You know what? When I was writing up this slide, my wife told me that apparently there's a TV series called Storage Wars, and this has nothing to do with it. I promise I don't know, and I don't watch that, so yeah. So anyway, this is a story about storage wars, and it's actually a very good time for HTML5. A lot of new things are happening. By the way, I put that in PowerPoint. It took a lot of effort, but I just wanted to highlight that fact. Anyway, so a lot of new things are happening. A lot of people are building exciting websites. Websites are doing things that they were not supposed to. And in fact, oh wait, what's that blinking? Is anyone using the Jedi mind trick to point out the fact that that is not from Star Wars? That's a Star Trek thing, right? I mean, yeah, anyway. What I want to highlight there is websites are going to places where they've never gone. And a typical place is the mobile or the tablet space. So this talk would typically focus on how to write websites that work great on mobile, that work great on tablets, and of course work great on the desktop browsers. So, oh yeah, before that, I haven't told you who I am. So greeting Jedi Lords. My name is Parashuram. I know it's a long name. In fact, my full name is Parashuram Narasimhan, which is like really, really long. So you can call me Axe. And if that's hard to remember, how about this? So that's an axe with a lightsaber. Can't get cooler than that. So yeah, you can call me Axe. And I'm a web developer. I like writing code, like most of you. And I contribute to open source projects. I write a lot of open source stuff. I like hackathons. In fact, I love hackathons. I've been to Disrupt. I've been to Photo Hack Day. I've been to multiple hackathons. And it's kind of a fun thing to do. And if my wife who's listening in on the live tweet, she's probably agreeing to this, but I play way too much games. I'm usually an engineer in Team Fortress 2. I'm usually a level 30 hunter. I'm still trying to level up. I just started on World of Warcraft. So I play way too much games. And yes, I'm not that person in the slide there. So I work for Microsoft Open Technologies. Microsoft Open Technologies. Give it some time, OK. It's a wholly owned subsidiary of Microsoft. The company just started in June, I guess, in 2012. And that's Jean Pauly, the guy who actually was a key part in doing XML. And that pretty much shows you how much the openness comes in. And Microsoft OpenTech actually has some really interesting projects. Microsoft OpenTech contributes to Node.js. We do PhoneGap. We do Couch. We have Jenkins running on Azure and stuff like that. So there are actually a lot of pretty interesting projects. And as I said, it's a wholly owned subsidiary of Microsoft. Well, if you have to build something big, what we need is a plan. And let's see what we'll do for the next 30 minutes. I guess I just have 30 minutes. So actually, you know what? Let's not build a Death Star, because there's already a White House petition that was rejected. There's also a Kickstarter project, so let's not build a Death Star. Let's do something simpler. Let me first try to convince you that you should build a site that's mobile first and functions offline. I know a lot of you are cringing here. A lot of you are not very comfortable with the fact. But let me try convincing you. Once I have, let me show you how it can be built. And then let me all try to bring it down as a pack of cards. Or must I say, bring it down like the Death Star. So yep, every one of us here wants to be a Jedi. So as a Jedi, let's choose our path. I do not know what you want to hear. So you'll have to help me out with that. You can either, so at every point, I'll probably give you 2 choices. Not the dark or the light side, but choice A and choice B. And you'll have to tell me which way to go. This effectively will also let me tell you what you want to hear. So let's actually get started. Do you guys want to hear about, should I really convince you that you need websites that work offline? How many want you to be convinced? How many of you want to be convinced? Okay, so you guys do not believe that websites have to be built offline, right? Okay, that's actually, how many think that it's okay we do need websites for offline functioning also? That's a minority. Okay, let me try convincing you. So all of us agree that web apps are for the internets. But then, you know what? We need our websites to work on this also. Is it true or not? Every time we build a website now, we want to build a website on this. In fact, this is actually a pretty beautiful image from the Joe framework, which effectively emphasizes that you can't just build websites for browsers on the desktop, but you also need it for the mobile browsers today. And when I say mobile browsers, you have a browser like this, or you have a mobile device like this, and then you get onto the airplane, and this happens. You suddenly lose connectivity. What happens to all the web data? What happens to all of the stuff you were browsing? They're probably in memory, but what if you close them and then open it again? Is it still going to work? Well, we don't know. No one has really tested it. That's probably one of the reasons why you should build it. And web apps are not just for mobile phones. Web apps are for operating systems too. I mean, B2G actually uses HTML, JavaScript, and CSS, and that's pretty much a web app. And if you're able to build an offline support for that, that's something you will want to, because you cannot expect phones or operating systems like this to be connected all the time. In fact, when I said operating systems, I'm also meaning things like this. So that's one reason. But then there are people who say that they don't care about the mobile. In fact, they actually believe that their internet is as fast as this. How many of you believe that your internet is as fast as this? No one, really? Okay. So you know what? This is not the truth. The truth is actually this. How many of you believe that your internet is as fast as this? Wow, that's a lot of people, okay. You know, I actually come from India, and this is probably true about the connections that I've been living with. But then I was hoping that the connections here are a lot faster. Looks like they're not. So here are the typical use cases for building mobile applications. Jokes apart, this is basically the crux of it. Why do you want to build offline mobile applications? You want to build it for mobile applications. You want to build it for applications that are disconnected. Typically things like to-do lists, or say image processors, or file processors, and things like that. You want to build offline applications for applications that are partially connected. How about, say, Outlook.com or Gmail.com having offline support so that you don't have to be online all the time to check your mail? You probably wouldn't need a thick client at all. How about things like calendars? How about things like those smart devices that people carry on the field? All of them need field devices. And then not just that, offline websites actually make your sites faster. You can have offline catalogs. You can have offline shopping carts and things like that. Let me give you a quick example of one of the sites that I had built. So this is a simple site that I built for demonstrating how good the conference Wi-Fi system is. Whenever you go to a conference, unlike a conference like this where the Wi-Fi is actually pretty awesome, most conferences have really, really bad Wi-Fi. And what happens, you want to look at the schedule, and they probably are distributing papers to you to show what the schedule looks like. I built this simple app that functions online and also offline. So what happens basically is all of the sessions that you see, all of the session information, all of the speaker information, all of it gets stored locally in indexed database, which is basically a database in your browser. And because of that, you can actually interact with the site when you're offline. And as soon as you go back online because of the flaky connection, your connection is restored, and all of this data gets synced back to the server. So that's a typical use case of why you would want to support offline in your websites. How many people are convinced that how many people are convinced that you want to build offline support? Not all of them, okay. You know what? This is what Darth Vader says. He tried to build something called a Death Star, and this is the schematic diagram of the Death Star. So it's like that red color planet there that was supported by deflector shields. And unfortunately for the Death Star, the deflector shields have to be online all the time, because as soon as the Rebel Alliance took down this happened. Death Star blew out of space. So if that can happen to the Death Star, imagine that if Death Star had to go offline and this happened, imagine what can happen to your website. Now are you convinced? Are you convinced, yes or no? Okay, nice. You know, when Darth Vader says something, people do get it. I don't know why. Anyway, so that was the first part of the talk where I convinced you, hopefully, that you should build applications for the offline web also. Let's see how to do it. It's easy to say why. The how is the part where we all come in. This is how a simple website looks like. It's typically a model view controller. I picked up this image from Wikipedia, but no matter, how many of you here use Backbone or any of the MVC frameworks? How many of you use only jQuery or only DOM manipulating frameworks? Oh, nice, that's a good number. How many of you use only JavaScript? Pure, native, good old JavaScript? Okay, nice. So regardless of what you use, you somehow store some of the content in the memory, which kind of becomes your model. Whenever you write JavaScript that modifies your web page, that is sort of your controller. And this is a diagram that typically looks, that's typical of most websites today. And what we do, all of our model is updated from data on the server. And that's how our entire single point of failure comes. So if you notice, if that arrow dies out, we are pretty much left in the dark. And that is why all you need to do is probably just do this and have that sort of cache kind of a thing that has data in the browser that then connects to the server. And it's actually just as simple as putting that support in your applications today. If you have existing websites, you don't have to do anything. You don't have to do a lot of code change. It's just that extra additional block that you'll have to put. So what are the options to store? Well, we've said about how. So let's look at what the options are. Cookies are actually a good option to store data in the browser. If you were to let's try to compare this with, say, transport mechanisms. How does storing data in the browser compare to transporting stuff? So if cookies was, I would like to equate cookies to something, it'll probably be this. Cookies are good, but yeah, it's probably not meant for it. I mean, let's just admit it. It's sent to the server all the time, probably not. Another option, another very good option is actually local storage. And local storage is something that's been around for a while. It's pretty stable. But you know what? There's one problem with local storage. It's synchronous. You'll have to probably have jump through the hoops, add it to a set timeout, stuff like that, before you can actually get it into an asynchronous thing so that it does not freeze your thread. And let's accept it. Local storage is not a database. You can't query. You can't do indexing. You can't retrieve all the records and then loop through them or stuff like that. So I'd probably call local storage this. It's there. It does its job, but it's probably overused. So, oh yeah, another choice. Do you want to see how we can probably pick up a Backbone application and use local storage for data storage? Yes? OK. So let me open up my favorite browser here. And so what you're seeing on the screen here is the To-Do MVC. It's a very well-known project on GitHub. How many of you here have seen the To-Do MVC project? Actually, a good number. So for the people who have not, To-Do MVC is a project by Adi Osmani who's picked up various JavaScript frameworks and written a simple to-do kind of an application. And what you can do is stuff like add a to-do list, and you should be good. And so this is basically a Backbone-based to-do JS application. It's running on my local system. I just picked up the Backbone one, for example. And let me show you the typical things that I needed to do for local storage. I actually had to just include this guy. Are you able to read the code? Yes, no? No, OK. Now? Now. So all you needed to do was include the backbone.local storage adapter. And what this guy does here, is instead of making REST calls to your server, it will pretty much intercept the REST calls, override the backbone.async method, and save all of your data to local storage. And you didn't have to change a single line of code in your actual existing Backbone application. You just added this, and everything worked magically. Adding offline support is actually as simple as that. You probably have to add support for syncing it to the server, but that's a different story. This is all you needed for getting started with local storage or getting started with locally storing database. And let's look at how it actually looks like. So let me close this. Let me go back to my browser, open this, and let's say. So if I open and show you what window.local storage is, this is all the information that's stored. So I actually can see what is stored in local storage, and it also shows that I'm not cheating. It's actually stored here. So all of this is stored on local storage, and it seems to be working perfectly well. It's just that one single line that I changed. And that's as easy as adding local storage. But as I told you, unfortunately, local storage has its problems. Local storage is sort of overused. You can't iterate through all the items. You can't query for a range of items and things like that. And that's when something good happened. Web SQL came in. And continuing our discussion on comparing storage options to transport mechanisms, Web SQL is probably this. Anyone can identify what this is? Pod Racer, yes. This is actually Anakin Skywalker's Pod Racer. It's a do-it-yourself kind of a thing where you are given this massive, super powerful engine, and you go ahead and write your own SQL queries and do all of your stuff. Life was awesome, actually. There's just one problem with that. The standards was based on an open source project. And the specification actually said that Web SQL should support SQL as in SQLite 2.13 or something like that. I actually don't remember the number. But it was actually specific to the version of the product. Now, that's probably not the best way to innovate. That's probably, so if you want to come up with ideas, you probably have to go change that spec and one specification depending on the other. That's probably not a great idea. And a lot of people in Firefox, a lot of people in Microsoft did realize that. And Firefox and Oracle and Microsoft suggested what is called IndexedDB. IndexedDB is basically a very, very primitive, simple, indexed-based storage system. So if SQLite is like this embedded database, the IndexedDB is one layer lower, and it's basically just indexed sequential access mechanism. It is exactly the same thing that Berkeley DB was. It gives you all the primitives that you need to build a powerful application. So if I was to compare this to something, you know what I'll compare it with? A lot of people call it so it is the sort of Millennium Falcon, but in the movie it was also called What a Piece of Junk. And that's probably a lot of people, that's what people think of the IndexedDB API also. I'll tell you why it is not. So, by the way, how many of you here have heard about IndexedDB? Do you want a quick refresher on the concepts, or do you want to have a quick refresher as to what concepts are there in IndexedDB? Should I do that, or can we skip over it? You want the refresher, OK. So, see, I had hyperlinks in PowerPoint. Isn't that great? So, what is this? This is your browser, or at least a mock of your browser. And IndexedDB, as I told you, is a database in your browser. So, yep, that's a database. It's inside the browser, so that's exactly what I'm telling you. It's a database inside your browser. And what IndexedDB does is it lets you store object stores. You can think of object stores in terms of tables. So so an object store is something that stores all your data. It's like a table in the SQL world. And inside an object store, you can have records. Those records are usually key value pairs. So you can have multiple key value pairs. And you can actually index on a value. So if you have a key value pair that says ID and a person's details, you can have specific indexes on the person's first name so that you can search people by their first name. Not only that, you can also iterate through all of them or iterate through a range of them using cursors on an object store. And similarly, you can have cursors on indexes also. You can have multiple databases inside one browser, and it's pretty much inside one domain. And all of these have the same security policies as cookies. It's pretty much the same cross-domain access restriction policies. If it's clear, great. If it's not, I'll probably run through this once towards the end so that you guys are able to get a feel of what IndexedDB looks like. But for now, let's just go back, given that I also am running out of time. So that's IndexedDB. And is IndexedDB clear? How many people are still not clear with IndexedDB? OK, nice. Do you want to see some sample code on how IndexedDB looks like? Do you want to get a feel of the API? Yes? Louder, louder. Yes. No? Yeah. OK. Let's look at some code. I'm sorry for the screen switching time. This is a really, really old laptop, so it's trying to keep up with all the advances in the web world. So, yep, let me open my browser again. And let me show you a tool that I kind of wrote when I was trying to learn IndexedDB. This is very similar to Dablet, or this is very similar to a CodePen and stuff like that, where it shows you the list of APIs, and then you can like execute them inline to see how they work. So for example, as I told you, there's a database, right? So is the code on the right visible? Yeah? OK. So to open a database, all you do is indexedb.open bookshop. And IndexedDB works on this request model, where whenever you call an operation, say open, for example, you are returned a request object. And it's not really callback, but request.onSuccess and request.onError are the callbacks that you get when the operation succeeds or fails. There's a very, very specific reason why, unlike local storage, this was made asynchronous. Because this runs on the main browser thread, you do not want to freeze the browser. Remember, this has support for things like transactions, which are actually pretty important. And if you're talking about things as intense as transactions, where you're writing to the file and do not want to come back till all of it is done or none of it is done, you want asynchronous APIs. You do not want to freeze your UI thread. That's why you have this whole asynchronous mechanism. There is also a synchronous version of the API that you probably can use in web workers, but as far as the browser support is concerned, that's probably not very well supported and may actually get dropped off. That's what the specification also says. So that's how you open a database. Do you want to see how to probably say create an object store? So an object store, as I said, has a key and values. So what you would do is you would say database.create object store. The name of my object store is book list. And the key is ID. And let me show you what happens when you try adding stuff. So if I want to add data, here's my sample data object. It has book name, author, price, rating, ID, etc. And all you have to do is you have to call it objectstore.add, and it tries to add the data directly. If you saw in the previous example, I defined something called a key path. What the key path does is pretty much takes this ID, which was defined as the key path, and keeps that the key, makes that the key of the whole record. So next time you want to retrieve it, you retrieve it by the ID. So that's what was done here. So that's what was done using the key path. I probably may not have time to go through all the examples, but I will be sharing the link to this site at the end of the presentation, and you should look at all the examples and play around with it. And do let me know if I'm missing anything here. And as I said, to probably say update data while you're iterating, this is what you would do. You have a concept called cursors, and you have this thing called you open a cursor. And once you have a cursor, what you do is when the cursor is opened, you'll have to probably do cursor.continue to iterate over it and stuff like that. You can also create indexes and search by indexes. So instead of getting something by just the ID, you can actually get it by the book name. And all you had to do was, let me show you, create index. Yeah, all you had to do was, so I told you all of these are inside transactions, right? I'll get to transactions in a little bit. But what you do is you do a create index. And in this case, I'm creating an index on price, which basically lets me retrieve based on what the price is, or lets me sort on the price. And that's what an index is for. And finally, as far as concepts are concerned, transactions, which are important. IndexedDB supports three types of transactions: read, write, and a version change transaction. What do you think read transaction does? What is usually a read transaction? It locks only while you're reading. A read-write is a lock sort of a mechanism for while you're reading and writing, and does not prevent any other read transactions. And finally, there's a version transaction, which effectively ensures that all schema changes, typically things like creating an index or creating an object store, can work only when there's a version transaction. Everything else in all other tabs, all other browser tabs, are stopped when a version transaction is in place. So that's the API. Do you guys get a feeler of how the API is? Yes, no? OK. Let's go back. So you know what index what is now. So you're not kind of confused. And you know what? IndexedDB still, how many people are still not very comfortable with IndexedDB? There are a couple, okay. You know what? When you're trying to tackle a problem as interesting as this, what you need is an alliance. What you need is helpers, people who can help you. That's the Alliance Rebel fleet. What you need is libraries. You'd actually be surprised to know that there are a lot of really, really good IndexedDB libraries out there that you can just drop in, and it makes your life a lot easier. There's a backbone adapter for IndexedDB, which I can show you. There is a jQuery adapter. All the people who love CouchDB can use the PouchDB adapter, and it's actually very, very powerful. It's one of the most powerful libraries that I've seen. And there is Launcher, and there are a lot of them. So question to you guys again. Which library do you want to see? How many want to see the backbone library? It depends on what, so the question is which is better. It basically depends on what your website already uses. If your website already uses jQuery, you probably wouldn't pick up the backbone adapter. So do you want to see how many want to see the backbone adapter? How many want to see the jQuery adapter? Okay, that's a lot. That's a bigger number. So let me just walk you through the jQuery adapter. Or actually, you know what? Backbone adapter is so simple that I can immediately show you how it looks like. So let me do that. I know I'm going against the common vote, but just trust me on this. It's probably going to be fun. So all you had to do was this. So remember I added this. Are you able to see the code? I'm sorry, I keep asking that. I love Windows, just for this feature. So you know what? This is the line that I added. Let me get, whoa. Yeah, this is where it gets tricky. You know what? Give me 1 minute. Oops. Whoops, give me 1 minute. I lost my, yeah. And I closed Sublime. Yeah, so, okay. So what I did here was added the local storage adapter. Let me comment it out. And let me enable the IndexedDB adapter. It's just as simple as this. And you are good to go. There's just one caveat that you have to know, and that is basically that the fact that, like for local storage, you added the single line of code. In your models and collection, you'd probably have to add these for IndexedDB, which basically tells what is the name of the database where you want to store, and what is the name of the store, or what is the name of the object store where you want to store the details. And in my case, I've kind of hard-coded all of them, but this will probably be called a to-do database, and this will probably be called a to-do list or something like that. And it's just that. All I had to do was add these, and every time I try to do a backbone.fetch or backbone.get or backbone.save, it'll actually write it to my IndexedDB. And that's pretty much all of it. Now, if people are not comfortable with Backbone, let's look at what the jQuery one does. So this is something I've been tinkering around for a very long time, and here's how the API looks like. You know, how many people like the request model where you say db open request.onSuccess? How many people like that? Not many. How many people love the jQuery promises concept? Okay. How about we wrap IndexedDB into jQuery promises? And if you do that, you get this. This is how simple the API becomes. All you say is $.indexedDB database name .transaction, and then you'll start a transaction. If you want to say, for example, if you want to add a database or add some event, for example, or add some data, all you do is you say $.indexedDB database name .object store, and where is the add? Okay, I'm not talking about add yet. Yeah, this is all you say: object store.add, object store.get, object store.put, and all of these return a promise. And you can do promise.done, promise.then, promise.fail, etc., etc. And using it is actually as simple as that. You don't have to know about any databases. You don't have to worry about any special request responses, any errors, anything like that. All of it is wrapped in and it's presented to you like this. So this is one of the APIs. Let me actually show you the best API now. You know what? One thing, if you noticed that we've been missing, is a simple fact that all of it is good, but it only stores data on my client. How do I synchronize it back to the server? Is that how many of you think that's a problem? Yeah, you know what? That's where the awesome PouchDB comes in. This is actually a community effort started by Dale, who works at Mozilla. And this is pretty much, the reason it's called Pouch is because it's portable couch. It's pretty much an implementation of CouchDB on your browser. If you look at the API, how many of you here like CouchDB? OK, not a lot of people, but nevertheless, this is how the API looks like. Let's say, for example, create a document. Creating is very simple. All you do is you do db.post, and then a document in Couch is pretty much a JSON object. All you do is db.post, and it will save it to the IndexedDB. And the best part, as I promised, is replication. And replication is, yeah, you also have support for querying, which is great. So what do you think this function does? What do you think this function does? It replicates from your client to your server, and it's clever enough to only replicate the differences. So you don't even have to worry about any synchronization. You don't have to worry about anything at all. Just say pouch.replicate, and you'll actually be able to replicate differentially from your client to your server. And there's a community around it, and these guys are actually pretty active in getting it up and running, supporting multiple browsers and things like that. Talking of multiple browsers, you know what? That's always painful, isn't it? So we saw the libraries. Launcher is also another great multi-browser, multi-adapter kind of a thing, but I'll get to that towards the end. But you know what? Talking about multiple browser support, this is the typical sentiment that all of us feel. Is it true? Yes, it is a trap. What about cross-browser support? Well, you know what? It's this, actually. On one side, there's IndexedDB. On one side, there's WebSQL. So IndexedDB is supported by Internet Explorer, Firefox, and Chrome. WebSQL is supported by Chrome, Safari, and Opera. That's like a 50-50 kind of a deal. So what do? You know what? When typically things like this happen, actually, you know what? Let me tell you a story. This is actually a bridge that connects Hong Kong and China. And the idea is the traffic in Hong Kong is right side. It's actually the other way around. So effectively, people drive on the right on one side of the country. People drive from the left on the other side of the country. In fact, I'm from India, and I drive on the left. In the US, you drive with the right. So people who want to move from Hong Kong to China or the other way, you could either put traffic lights, stop all of them, let one traffic merge into the other, or come up with something clever like this. And this is actually the idea of a polyfill. So I actually tried doing a little bit of an animation here showing you how the traffic goes. But you know what? Don't worry about it. It's kind of crappy. So that's where polyfill comes into play. And a polyfill is effective. So this is a polyfill that I've been working on for some time. It kind of covers 90% of the cases. There's still a little bit of part of IndexedDB that doesn't work. But for all practical purposes, for all applications, you can actually use the polyfill. In fact, the polyfill pretty much exposes IndexedDB to web application, and it actually works on Cordova too. So technically, you can write IndexedDB API and get it running on your PhoneGap applications. And to give you a quick idea of how the polyfill looks like, let me open up Opera, which does not support IndexedDB. And what I do here is, this is a simple IndexedDB application where, actually, let me open this up in Chrome also. I've showed you all the browsers, haven't I? Except Safari, I couldn't get it installed. So is my internet down? Probably, OK, not really. So what happens here is if I go to the resources tab, and if I say refresh, you can actually see the list of all the databases that are here. And these are so the sessions and the user preferences were for the previous demo, but my e-commerce site is the IndexedDB database. And this is actually all the content that's supposed to be in the IndexedDB. So you can see the catalog and stuff like that. And all of this is stored in IndexedDB. Because Chrome supports WebSQL, there is WebSQL, but nothing else happens. Let's actually look at Opera now. The exact same example works, just that in case of Opera, if I'm able to click, it's not stored in IndexedDB because it's not supported. It's actually stored in WebSQL. And this happens due to the polyfill, which effectively means that you can you can actually write offline applications for almost all applications. So it looks like it was not a trap after all. Quick recap. Anyone guess what these images are? They are Yoda from all the 6 movies. So sort of a recap. The Yoda from the first movie kind of looks creepy though. I mean, look at that. Actually, you guys are lucky that you don't see it in this light. Yoda is staring right into my face here. So quick recap. Through this session, we saw what IndexedDB is. Are you guys convinced that we need to write applications for the offline world? Yes? OK. Do you guys think it's easy to write applications for the offline world? Yes? No? You don't know yet. That's actually a good answer. And you should, if you don't know yet, the only way you'd probably know is if you try. And there are multiple libraries out there that you can actually use to see if it works. And there are people in the community who can actually help you out. You should probably try that. And finally, we also saw what the polyfill was. That's all I had for my talk. Here are all the links that you would need. And may the force be with you. Questions, please.
So I remember a couple of years ago when people were trying to deprecate Web SQL, they were saying that IndexedDB was a lower level thing where you could actually use it to build more complex stuff on top of it. I'm wondering if that is actually the case. I don't think I've seen, I'm not very informed, but I don't think I've seen any very complex querying engines on top of IndexedDB. Do you know anything about that?
So one of the reasons why IndexedDB did not support querying is SQL is not the only way of querying. There are multiple ways of querying. SQL is just one of them, and Web SQL did just that. So if you were to look at the whole database stack, and I used to be a program manager at SQL Server, and if you look at the database stack, there's this initial database, there's this low-level database engine that probably is responsible for saving data and minimal things like creating indexes or iterating through data. The query layer is actually built on top of that layer. Web SQL gives you the whole thing. IndexedDB just gives you that small index layer. And there are people who have written JavaScript libraries that can do querying for you. So there are people who have written SQL kind of querying. In fact, the LLVM ECMAScripton project converted SQLite to SQL.js. You can actually pick up that querying engine and plug it on top of that. And that's one of the things I'm working on right now. You can use that kind of a thing. Or you can use Hibernate kind of a query language, or a more JavaScript-ish kind of a thing where you can use JavaScript functions to query. So all of them are actually being written. So so you're going to have options because of this transition, and you're not limited to being SQL as your only query language. So does it answer your question?
Yeah, that was my question.
First, thank you very much for this talk. This was great. Do you have an opinion on Meteor.js and Firebase?
Opinion regarding local storage itself, or?
Well, with Meteor, my understanding of it is that it's a framework and data store kind of in one. Do you feel like this is a way forward, or do you favor having those separated completely?
I think it's kind of a hard question to answer given the generality of it, because it's probably going to be dependent from one project to the other. But I think in general, it's a great idea that people are thinking about integrating the whole data aspect into their applications. And Meteor, or even Backbone for that example, has this thing about the whole concept about supporting data itself. So I personally believe that jQuery is probably a good base to start with, but people are going to start writing MVC apps, and a data-driven approach for like Meteor or Firebase is actually pretty good to go.
Thank you.
I'll be hanging around somewhere down. So if you have any questions, if you need help with if you want to think about how to get your existing projects running on, say, IndexedDB, please do come and talk to me. I'll be more than happy to help you guys. Thank you.